As you guys can probably tell, this is a Spike Prime Lego brick color sorter using a single color sensor and 3 motors. It has the Spike Prime hub at the back, which controls everything. And it works by placing a brick in this top funnel, which it then slides down, and then when the color is detected and I play the program, it'll be sent, not like that, but it'll be sent to its original color section. So if I put a blue here, it'll fall down. I put a green, and the same thing with the yellow. It basically works by having a color sensor here and a bunch of loops. It'll always be trying to sense a color that's either red, yellow, green, or blue. If it does, it'll play the code to send that brick to its right sorting spot. Once it detects what color it is, it'll use this big motor over here to kind of slap it in the direction that it needs to go. Then, depending on whether it's going to the far side or the inside, so if it's red or yellow or if it's green or blue, it'll raise this bar up to let it either fall in here if it's yellow, or it'll keep it down if it needs to just slide into the red spot, and same thing with the green and blue. It's a pretty simple thing and it's not too complicated. It doesn't have too many pieces. It might look big and scary and very complicated, but I promise you it's not. Let's get into the code. Okay. So for the code, you can see that we initially start with motors A, B, and C being set to 100% speed. I did this so that it has the most amount of power to push, especially for A, because it does the initial sorting. I gave it the most amount of speed, which gives enough power to push the bricks to the side they need to. A is the motor on top that does the initial sort between left and right, left being yellow and red and right being blue and green, but I gave it enough power so that it operates smoothly and is able to push the brick far enough so that none of the bricks above it get stuck. This allows for smooth operation and, most importantly, quick operation. B and C can be set to a lower speed if you want to, but I just like to keep it uniform, but that's totally up to you. B and C are the right and left motors respectively. The B motor lifts up when it detects a green piece so it doesn't accidentally get pushed into the blue section, and the same for C with the yellow. It flips up when it detects yellow so that it doesn't fall into the red section. But when when the color sensor detects either red or blue, it'll stay down, which leaves the ramps to guide the red to the left and blue to the right when needed. After the setting of the motors and their speed, we go into forever loop. This forever loop ensures that while the code is running, the color sensor is always making sure that there's no brick being detected and there's nothing that needs to be sorted. If and hopefully when there is a brick that is put into the funnel, the color sensor will detect what color it is and then play the appropriate program, depending again whether it's red, yellow, green, or blue. And each one has, well, actually the yellow and green code is mostly the same, and the same it goes for the red and blue. So let's just look at the red and blue first. Because the red is on the left side, motor A has to turn right 45 degrees to let the brick fall down, and then it has to turn left more so that it can push the brick out of the funnel and to the left side. And you'll notice that it pushes the brick left more than it swings right. This is because it needs to just go all the way to make sure that the red brick is fully going down that path. And because it's going farther, it needs to return back to its original spot, which means spinning in the opposite direction 13 degrees. The same kind of idea is going on when the color sensor detects blue, except it's just going in the opposite direction because blue is on the other side of the sorter. It has mostly the same numbers, just a little bit of variation, but that's just my tweaking of the code based on how my motors are running. And actually, you'll notice that these numbers are very odd and not like a whole thing like 60 and 10, but that's actually because all the motors are slightly different in how tight they. Let me show you what I mean. When you work with any Spike Prime motor, most of the time it's not going to be fully controlled and fully responsive. It's going to have this little bit of wiggle room, which is not a problem. It's just sometimes you have to code for that little bit of extra wiggle room. As you can see here, I'm wiggling the motor a little, and even that little wiggle is a good 2 or 3 degrees, which you have to account for when you're writing the code. It's not a problem with the motor, it's just that over time as you use these motors more and you like force them sometimes when you're moving your robot or an attachment or like a little functional thing, and it's not done with the code, even with the code, it just wears over time and becomes less stable and more prone to being wiggly and having some variability in its starting position. You can sometimes control it by forcefully spinning it to the exact position you want, but you're sometimes, or most of the time, going to have this little wiggle that just changes your code a little bit. It's not too significant, but it's just enough to need some attention. It's not a huge problem, like I said before, it's just something you have to account for, and that's why my numbers are just a little off and not perfect, like 60 and 15 and 20 and all of those nice numbers. It just depends how old your motor is and how much you've used it and how much wiggle it has. This is something that you get these values just by trying and seeing what works. I had to try this multiple times to see that, okay, these numbers are the final ones that I see that are able to work and work well. Coming back to the code, we see the yellow and green code is slightly longer and a little more complicated. The only reason this is because of the fact that the motors B and C have to rotate to prevent them from going onto the outer edges of the sorter where the red and blue bricks go. The extra code is written at the front or at the top and at the bottom of each little segment. So as you can probably see on the red and blue sections of the code, it's only A running, and it's running one direction, the other direction, and then back in the other direction. For yellow and green, we have to do a little more work with C and B, respectively. So for C, we have to lift the ramp up by 40 degrees, and keep in mind both or all 3 motors are running at 100% speed. So we have to rotate C up by 40 degrees, and then we do basically the same code as D, or not D, red, and then we just flip C back the other direction down 40 degrees, which can prepare it for another potential red, or it'll do the same code if there's another yellow coming up. The same idea is for green. It's kind of like the same idea for blue as to red. It's just doing the same thing with a different motor and the opposite direction. So B has to lift up, and then it'll run the A code to push it in, and then B will flip down for the next brick that potentially either is blue, which will slide down, or a green, where it'll lift up again. The only thing is you have to be careful about looking at these motors and what direction they're turning, because when it has these rotation arrows, you have to look at it from the part that spins. Let's take a look. Okay, I'm just using the same motor here, but what I mean is, for example, if it's turning clockwise, which is this way, and the arrow on the code is pointing right, it just turns to the right. And the same thing when the arrow points to the left and it's turning counterclockwise. And this is the direction you should be coding from, because this is the way the motor takes the code. If you code it from the back, which is how it is on the sorter, as you can see here, it'll be the opposite way, or flipped, because now when you're turning right, that same right is turning left. And when you're turning left, that same left is turning right. So if you don't code it from the right direction, then the code can mess up, which sometimes is not a big deal, but sometimes it can be a little bit more chaotic if you have some big and complex pieces of code. So you just have to be aware and kind of think of it as, okay, I'm looking at the motor straight on like this. So what direction is it actually turning? Is it turning to the right like I want it to, or is it turning to the left, which would be if I was looking like this? So yeah, that's basically what I mean. It's kind of applying that concept to motors B and C, because if I'm looking at it from here, and let's say this is motor C, where it has to turn this way to let the yellow in. If I have it turning to the right, it'll go down, even though that's what it looks like from here. But it's not what is actually needed from the point of where the motor actually spins. And the same thing for if it goes the other way for B and the other directions. Okay, let's just take a quick look at all of these pieces of code running separately. So here I'm putting a red block, and as I put it, it falls, and it should be nice if I played the code, but when I play it, it detects and smacks and successfully, I guess, sorts it to the red side because the motor C didn't move, which is good. And then we'll test the yellow block. So we'll place it up here, it detects, C lifts up, A pushes, and then C comes back down. Then moving on to green, we can put a block up here, it'll fall, it gets pushed, but not before B lifts up to let it fall down, and then once it's pushed and enters the section, motor B falls back down. And finally for blue, it's the same idea as red, it'll fall down and get pushed all the way to the other side. And yeah, that's basically the color sorter. I hope you guys liked this video, and if you did, don't forget to go down and hit the subscribe button so you don't miss out on any future videos. Thank you. As you guys can probably